Okay, let's talk a little bit about the process that these actually go through. So when a machine connects to the network, it needs an IP address, and it's going to get it through DHCP. In this example right here, we're going to say that both these are DHCP servers. And the reason why both are DHCP servers, the reason why you would have two DHCP servers, is because if one goes offline, then the other one will be online to to fulfill those requests. And so usually, or a lot of times, you'll have a couple different DHCP servers on your network. So we're going to have two here. This machine is going to send out what's called a DHCP Discovery and says, hey, I need an IP address. Please give me the information you got. And then one or both of these machines will respond back. That response back is called the DHCP Offer. They're offering an IP address to this machine. The next step is this machine is going to request then one of those. If it's getting two offers from two different servers, then it's going to request one of those IP addresses from one of those servers. And then finally, there's an acknowledgement that happens back that says, okay, you've got it. And so that's the four-step process: a discovery, an offer, a request, and acknowledgement. All right, let's take a look at this DHCP process a little more in depth. The first thing that happens when this machine connects to the network is it's going to send out a DHCP Discovery frame. So that frame, and I'm calling it a frame because it's going out layer 2, right? So on the layer 2, on this network, this local area network, it's going to send this frame out, and it knows its own MAC address. So it has a MAC address that's burned onto that network card. It doesn't get that information. It already has that information. So the sender can use its own MAC address as it sends it out on the network. What's going to happen then is that's going to send out as a broadcast. A broadcast is all F's in the MAC address. So it's going to send it out to the switch with all F's in the MAC address. It doesn't know where it's going to send to, so it just has, it doesn't know its own IP address, so that's 0.0.0.0. And then it's going to send it out to a destination IP address of 255.255.255.255, which is a broadcast IP address. It's going to use the source port, a UDP port of 68, and going to use a UDP port of 67 as the destination port. So this is the server, this is the client. Okay, so it's going to send this out. It is a broadcast, so this switch will broadcast it out in all other directions. It's going to send out this DHCP Discovery. In this example right here, we're going to say that these two servers are both DHCP servers, and we'll see how this interplays with two DHCP servers on your network. The next step in this process is the DHCP Offer. The DHCP Offer is going to be these machines, these DHCP servers, making an offer to this computer right here. Now, it's going to send out, it actually knows the destination MAC address now. This machine, as it sent the discovery out there, had its own MAC address in there. So it can send it directly to this machine right here. So it's sending from these machines. They, of course, know their MAC address. So the sender MACs will be the sending machines, or these servers right here. The destination MAC address will be of this machine right here. The source IP address will be of these machines as it sends it out, because they have an IP address that's assigned to them. So that'll be the source IP. The destination IP is going to be what they're offering, the IP address that they're offering. So these machines are going to be offering an IP address to this machine right here. And the source port is going to be 67 and destination port is going to be 68. So 67 because it's sourcing from the server, and 268 because that is the client machine. So that is going to be the offer that's going to be sent there. This machine is going to get two offers because there's two DHCP servers out there. Now this machine is going to request one of those. So it's going to do a DHCP request. So let's say it's going to request the IP address that was sent by this machine. So it's going to send it out, and of course it knows the destination MAC address. But look, even though it knows the destination MAC address because it's received a frame from this machine already, it still sends a broadcast out. It's sending all Fs and all 255.255.255.255 for the IP address. So this is still a broadcast as it sends it out. And so the question is, well, why would it send a broadcast out that's going to be sent out in all the directions? And the reason for this is it's accepting the IP address from this machine right here, but this machine also made an offer. And it is a broadcast because then this information gets gets the frame in there and realize that you are actually accepting or requesting the IP address from the other machine. So then it can actually put that back into its pool to be handed out to someone else. Versus this machine then will then take the next step, which is going to be to acknowledge that you accepted the IP address that it sent. So as this machine has the acknowledgement and is sent back, it can do the sender's MAC address, destination MAC address, its source IP and the destination IP. And once again, the source will be from the server, so it's 67, UDP port 67, and the destination is to the client, so it is the destination of UDP port 68. So then it completes this exchange and is successful with this exchange. So, and it knows all this information because it's just a standard frame at this point in time because it's got all of the information it needs for communication back and forth. And from here on forward, this can send standard frames out onto the network because it has an assigned IP address. Thanks again for watching my video. If you liked it, could you hit that like button?